Hi, Algebra 2. In this video, we're going to be working through lessons 3.1 and 3.2, starting our work with polynomials. Here we go. The first thing we have here is a little bit of vocabulary. First thing we're looking at is monomial. Mono means one. So these all have one term, which means a number like 3 being multiplied by a variable and an exponent, like so 3 times x to the 4th, or 1/2 times x to the 7th, or maybe no coefficient, which in this case we know is 1, being multiplied by multiple variables. Poly means many. So when we're looking at these, they're going to have one or many terms put together. Down here, these are examples of things that are not polynomials. Here we have x as an exponent, that is not a polynomial. Here we have absolute value happening, that's not a polynomial. Here again we have the square root of x as an exponent, not a polynomial. This one sometimes trips us up. We cannot have variables in the denominator, so that is not a polynomial. And here we have a coefficient that is not a whole number or an integer, so that is not a polynomial. First thing when identifying polynomials, we're going to look at degree, which is the sum of the exponents. So in A, the degree of this one is 6. In B, this one is 0, because we really could have a variable to the 0 power there. Anything to the 0 power is 1, and so the degree there is 0. In C, this is like x to the 1st, and so the sum of those exponents would be 4. And in D, the sum here would be 6 if you add up all those exponents. When we write polynomials, we do have a standard form that we write them in. This is like the grammatically correct way to write them in math. We start out with the term with the highest degree first, and then the next highest degree, next highest degree, next highest degree. And then the leading coefficient is the number that's being multiplied by the variable with the highest degree. And so in this case, the leading coefficient would be 5. It's going to be out front when you write it in standard form. If you have a polynomial with lots of different variables like x's and y's, then we generally put them in alphabetical order if we can, but sometimes it gets a little messy. So standard form is really just for when we have only one variable. We have different names for polynomials based on their degree. So if you have something with degree of 0, that's going to be a constant function. If you have a degree of 1, that's a linear function. Degree of 2, that's a quadratic. So far, these are the two we've been working with this year. Degree of 3 will be called a cubic. Degree of 4 will be called a quartic. And degree of 5 will be called a quintic. Then we can also name them based on the number of terms. A polynomial with 2 terms will be called a binomial, bi meaning 2, and a polynomial 3 terms is called a trinomial. So we classify them based on their degree and the number of terms. So example, we could call something a quadratic binomial. First thing we're going to do with these 3 examples is rewrite them in standard form. So go ahead and do that for each of those and start again when you're ready. Here are each of them written in standard form. Notice we're starting with the variable with the highest degree, and we keep that coefficient with them. Next, we're going to identify the leading coefficient for each of them. So for this first one, my leading coefficient is going to be -5. Next thing we need to do is identify the degree. And so the first one would have a degree of 2, B would have a degree of 4, and C would have a degree of 3. Next thing we're going to do is name the polynomial. So for this first one, this would be a quadratic because it has a degree of 2, trinomial because there are 3 terms. The next one would be a quartic because it has a degree of 4, and it would be a trinomial because it has 3 terms. C would be a cubic because it has a degree of 3, and it would be a polynomial because it has more than 3 terms. When we add together polynomials, we're really just combining like terms. I did rewrite these in standard form just to make it easier so I don't miss any terms, but I am going to show you how to add them vertically because it can be a little bit easier. So when I'm writing these vertically, I just wrote out my polynomial. I left a space in this one because there was no x squared term, but I'm lining up my like terms vertically. And so when I add them together, it's a little bit easier to see all of my like terms. And when I combine those like terms, this is what I end up with. Subtracting is a little bit different because we're not simply combining like terms, we are subtracting each of these things over here in parentheses. Again, I wrote these in standard form just so I don't miss anything, and I'm going to write this out vertically so that you can see what that would look like. Here it is written vertically. I've left space where there is no term. Like here there is no term with just x. Here there is no term with x to the third. The trick here is to remember to subtract everything, and sometimes we miss those negatives. So sometimes I will actually put this part in parentheses just to remind myself that I am subtracting everything. And as I start subtracting, that first term is pretty easy. This next one, 6x squared minus 15x squared. So that's going to be a negative 9x squared. The next one, I have 0 minus 3x. So that's going to be a negative 3x. And then I have 12 minus a negative 2. Subtracting a negative is the same thing as adding. And so here's what I end up with. In this example, we are just kind of reviewing how to use function notation with our polynomials. So it says to evaluate f of 0. So here's f of 0. I plugged in 0 for x, and if I evaluate that, I would see that f of 0 equals 45. So we need to also describe what that represents. That means if I manufacture 0 units, it will cost $45. And when I evaluate f of 200, I get this really big number. What that means is that 200 units, to manufacture them, will cost that much. When we start looking at these polynomials on a graphing calculator, we start to see some really weird shapes we haven't seen before. Here's our first function graphed right here, and the number of real zeros is going to be 1, 2, 3. It's the number of places that it crosses or touches the x-axis. Here is function b, graphed right there, and it's going to have 4 real zeros. 1, 2, 3, 4. In lesson 3.2, now we're going to be multiplying polynomials. The big thing when you're multiplying polynomials is to remember your distributive property. I like to draw arrows with that. And remember that when you're multiplying, if you have the same base, like I have y's right here, I can add those exponents. So 4y squared times y squared would be 4y to the 4th, and that would be plus 12y squared. Going to our next one, fg times f to the 4th would be f to the 5th times g. fg times 2f to the 3rd times g would be 2f to the 4th times g squared. And fg times this next term would be negative 3f to the 3rd times g to the 3rd. And our last one would be plus f squared times g to the 4th. Here's what you end up with these two. And remember, it's just doing the distributive property over and over and over again. And when you're multiplying, you can add those exponents. So for example, this is c to the 1st times c squared would be c to the 3rd right there. This slide is just to remind us that we can do the distributive property with just one term like we've been doing, but we can also do it with a second term, and you just keep doing the distributive property over and over and over again with every term. All right, so we're going to multiply these two together, and we do want to make sure that we are keeping track of every piece here. So I'm just going to keep using my arrows to write this out. Then I'm going to switch colors, and color coding is sometimes a little bit easier. When I'm multiplying this, remember it is negative 3 here. So this would be negative 3 times negative 5a, so that'd be positive 15a. Negative 3 times a squared would be negative 3a squared. Now I do need to simplify and combine all my like terms and put this into standard form. So I have positive a to the 3rd and negative 3a to the 3rd, so that's negative 2a to the 3rd. Then I have negative 5a squared. Then we have 2a and 15a, so that would be 17a. And then we have a negative 6. So there it is, multiplied and simplified. Now, once you end up multiplying with trinomials, that distributive property can get really cumbersome. So here's another way you can do it with a table. And you'll notice that we put one trinomial with all its terms on the side, one trinomial with all its terms across the top. And then you're just multiplying. This reminds me of like a Punnett square in biology. And we just keep multiplying all of our terms. So this is what the table looks like when we finish multiplying, and now we combine our like terms. The nice thing is that if we were in standard form when we set up the table, our like terms tend to be in groups diagonally on our table. So I have 1y to the fourth, then I have negative 8y to the third, then I have 9y squared, and then we have 16y and a negative 15. So there it is, all multiplied out. The table can really help keep things organized. All right, here's one for you to try on your own. Multiply this out. You can use either the distributive property or set up a table, whichever way you want. So I used a table. You can see that right there. And now when I'm combining like terms, again, they are a little bit organized. So I have my 9b to the third here. Here I have like terms because they have the same variables with the same exponent. So it's negative 6b squared c. Here's some more like terms, same variables, same exponent. So it's negative 6bc squared. And then positive 2c to the third. So there it is, all multiplied out. All right, Algebra 2, so there you have it, identifying and classifying polynomials, and then you were adding and subtracting and multiplying with polynomials. Make sure you're asking questions as you work through this stuff. Great job, guys. Keep it up.